The idea of the project is that we take various samples of biomass, for example, green waste, which is readily available at the Rockhampton Municipal Tip. Other sources would include bagasse, which is the fibrous material that you're left with at the sugar mill after you've extracted the sugar. The example here is green waste. Then what happens is that samples of this material are subjected to a process known as pyrolysis, and we can distinguish pyrolysis from combustion, where you burn material. The distinction really is that when you're doing pyrolysis, you're excluding oxygen.
So I'm going to produce biochar by using these two source material in 4 different temperatures, from lower temperature 400 degrees C to higher temperature 800 degrees C. Then I'll have a different types of biochar. Then I'll characterize this biochar. You know, what are the nutrient contents in biochar, how much carbon content, something like that. The reason behind this characterization is optimization in the production method.
What happens at those high temperatures is that chemical reactions occur which break down the organic matter, and what happens is that you're left with a material which is essentially similar to a charcoal. It's known as biochar. I've got a sample of it here. That has interesting properties when you introduce it back into the soil. It can enhance plant growth. It can sequester carbon, which people are very interested in these days. So you can think of the material as fulfilling a similar function to the suggestion that you bury carbon dioxide in the ground.
We've been working on the green waste for the past 10 years, trying to look at the value, adding value to that waste. For example, Rockhampton City Council produces about 90,000 cubic meters of this waste every year. It will be coming all the time, and they can't give it away. And so we started looking at making use of this waste as a mulch, compost, and various other options, but none of them were really, there was no demand for those commodities in Rockhampton. So recently we started working on converting that into bioenergy, biochar, and bio-oil. By adding biochar into the soil, we can minimize the losses from the soil. And at the same time, if we take the biochar and add it to the soil, and that biochar will stay there for thousands of years. And so just to give the Rockhampton scenario, we produce about 90,000 cubic meters of green waste. If we convert that into biochar, we will get about half of that will be biochar, and half of that means roughly about 30 to 40,000 kilograms of carbon is produced. And if we put that back into the soil, that carbon is locked up in the soil for thousands of years. This is one way of making use of the waste and also preventing the carbon dioxide going into the atmosphere to prevent the global warming.